Hi everyone and welcome to this session on observability and monitoring of NSO. We're going to find out what goes on inside. So I'm Kristian Larsson and I work in the Cisco NSO CTO team, and for the last 6, 7, 8 months or so I've been working on this topic of observability and monitoring of NSO, and I've built a little package that I'd like to show to you today. And we're going to sort of do an introduction to the overall concepts of observability and monitoring. So this is the introduction session, and I will also be following this up with a deeper dive into the underlying technology and all sorts of things around it. And I think that will be available as an on-demand video. So we're going to start here with sort of a situation or a scenario that you have probably found yourself in at some point, right? So we're going to use the NSO CLI here to configure a service. So let's say slow service test. We're going to set something. So as soon as you've set your parameters for your service, we're going to issue a commit, right? A commit, and then nothing happens, or at least so it appears. Now our NSO system is something like a big black box. We can stare at it and we know it's there, but we still haven't gotten our prompt back. So what is it doing? Observability means that you can answer any questions about what's going on the inside of a system just by observing the outside. So in order to achieve this, we need to expose enough information about the insides of the system, of NSO, so that we from the outside can form an understanding of what is going on. Fortunately, NSO has this interface API called progress trace, which allows us to extract this kind of data, and I have written this package that transforms that and exports it to common off-the-shelf tracing and graphing systems. Now, the easiest way to look at progress trace is to append pipe details to your commit in the NSO CLI. So let's make another configuration change and look at the output. We can see here as well that we did actually get our prompt back eventually. So let's do another change here. I'm going to create another service instance, and this time we'll pipe it to details. We can also set the verbosity level here, so I'm going to set it to very verbose and then run that command. And now we can see that we get some output here, and this is a progress trace, right? It starts out applying transaction is the first span, and this is the first event. The 3 little dots here at the end indicate that this is the start of the span. We can see we find at the very end the corresponding stop event. Here we have applying transaction. It will instead say OK because it was successful, and the time it took to run the entire transaction, which is just over a second. A transaction in NSO consists of 4 different phases. We can see them laid out here. You have entering the validate phase, so this is the start of the validate phase. It goes on down to here where we have the end. Then the next phase, which is write start, we have prepare and commit. And then within each phase, various things are happening, right? You grabbing transaction log, rollback file, we run the actual service. And I don't know if you noticed this when I was running this, as progress trace is output in real time, we could actually see here that it paused right around here, right? We could see how we got this output, and then it paused for about a second. So if you haven't figured that out or guessed it at this point, the slow service that I created here is a service that has an artificial sleep in it. So we configure the time that the service should sleep, and that's what it does. So we see here this step is what took a second, which is also the majority of the entire transaction is just spent inside of this sleep, right? This is a small transaction. We're just committing a single service. It doesn't do anything really advanced. There are no devices involved or anything like that. No HA as well. So that means that the entirety of the progress trace is fairly compact. It's quite short. And figuring out where we're spending time is not that difficult. You can sort of see it if you ran it and looked at it in real time. We also notice sort of where it paused. Nonetheless, if we have a larger transaction, we're committing many services, maybe hundreds of services even in a single transaction, then the same thing is not true. We'll get progress trace output that is thousands of lines long, and if we have device interaction, that will too add on to this, right? So finding out where you're spending time can be a lot more difficult. We're gonna take a look here. I'm gonna back out of the CLI. Print, and we're gonna jump into Jaeger UI. So Jaeger is a distributed tracing system, and this is the web interface of this system. So what we're gonna do is just pick NSO. It's the only service here available. Note how service here is the Jaeger services, not NSO services. And I did a find, right? So 2 traces pop up in this system. Which is perfectly natural, because since NSO started, we have performed precisely 2 transactions, right? We're going to take a look here at the second one, which is the one I just committed, and here we get a visual overview, or a visualization really of the same progress trace data. There's an overview here at the top. We can choose to zoom in to a particular section of it. We can also see here some summary data. We have the duration as a second that corresponds. Let me bring up here the terminal. The entirety of the transaction took 1 second and 32 milliseconds, right? Which rounded off is 1.03 seconds. You can minimize this for now and make it slightly smaller so we can fill a bit more. So you remember the CLI progress trace output here. We have the different phases in a transaction. We can see the same thing here, right? So under this applying transaction span, we have these 4 phases: validate, write, start, prepare, and commit. And already here we can see sort of the main benefit, or really of the visualization. The length of the bar here very clearly shows how much time we spent in each phase, right? So here we can see write, start, prepare, and commit just took a few milliseconds, right? Where the absolute majority of time was spent inside of the validate phase. We can expand this, and again, comparing these different spans, it becomes quite evident that running the transforms and transactions hooks is where we spent the majority of time. And we can drill down all the way to the create span, and under that we even had this sleep configured span. So I think this is a great way. The data, I mean, you want to figure out like where do we spend time inside of our services or inside of NSO, and it just jumps at you here, right? You can immediately see where we're spending time. Most of the things in traces, this is a sort of a structured format, right? So all of these different spans that we have, they relate to each other. You have a parent and a child span that also becomes clear from this hierarchy, which ones are siblings of each other, and they are the child of the parent above them, and so forth. So it's a structured format, which again sort of helps when you're digesting this information. If you want to parse and analyze it further, it makes it easier to sort of consume. With each span, we also have attributes. So I can expand one of these. If you notice, the name of the span is just create. It doesn't say which service was created. So this is instead associated with or added in as attributes. So if I expand this one, I can see the tags that are associated with it. Like context, the data sort 2, I think means the running database. Here's the message, and it's important here that we actually void instance data or variable data inside of these messages. So compared to typical log, in a log you'd see variable data. It would say, now I am executing the create function for the given service. Right? We sort of extract that here and place it instead as a separate attribute. So in this case, it's simply called service, and this is the key path, right? Or the, yeah, it's like an XPath to that service instance. There's another nice feature. I'm going to talk more in the deep dive about the differences between different signal types that we have in observability, logs and traces being one of them. And they're not completely sort of mutually exclusive. With traces, we can actually combine this with logs. So in Jaeger, this is visualized. I'm going to zoom in here at the end where I know there are a few spans that have log messages attached. And here we can see, so in Jaeger, this is visualized by the span having this black bar on it, and that's where you have log messages. So if we hold the mouse there, we'll get this. We can see that this is the log message at that point in time. You can also just expand it and see here we have the log message. It's not much of a classic log message. You know, the message is just write start in this case. So it's fairly short. But nonetheless, it's possible to attach logs, and this makes it very easy, right? I mean, you get the structure of traces. So when you're trying to discover and look at your data, you can do queries on the structured format. You want to find, let's say, certain transactions that have taken more than 10 seconds. And then within those, you want to look at, did I have device interaction, and maybe filter on certain net IDs. And then you want to look at the log messages for that. And that is possible with the tracing format. So in observability, we have data both on a high and a low level. So what I've shown so far is tracing, which is a very good tool for understanding low-level kind of things. You know, we look at a single transaction here, and we can understand the parts that it comprises, the different phases and the different operations in that transaction. We understand where we spend time, and we have various details as attributes, etc. in there, right? So the other end of the spectrum is getting more of an overview of a system. We want to, you know, is my system performing well? Is it highly loaded? And for this, we're instead going to resort to metrics. NSO doesn't expose any metrics itself, but we can use the same progress trace data that we use to render our traces from to also produce metrics. So let's see here. I'm going to open up. We have Grafana. I'll make that full screen, slightly smaller. We're going to end up something like that, and probably slightly larger time span. Okay, so this is a ready-made example Grafana dashboard that shows some aspects of NSO. All of this is running in a test environment inside of this repository that I've created, right, for this NSO package that does the export. So all of it. So if you want to play around with this, all of this is open source, and you can go find it. I'll link it at the end. But anyway, so this dashboard it shows a couple of different things. We don't have that much data. We've just run 2 transactions at this point, right? So there's not that much data in it, but we can see some of it, right? So here we have the mean time in crate per service type. There's just a single service type in this case, so it's fairly uninteresting. But if you have, well, your real production system, or maybe you'd run this in CI and you could test all your different services, then the output here would look a lot more interesting. Here's an overview on the left side, this transaction duration. So this is a histogram showing the transactions that we've had. We've only had 2 in this case. One of them took about a second. So this shows that for the bucket with 1 second in it, then we have exactly the count of 1 in there. The other transaction took 60 seconds, so we have a bucket with 60 seconds, and there's 1 transaction in there. But as for a real system, right, then if we look at a longer time span, you'll see that you have hundreds or thousands of transactions, and you can sort of see the shape of this and understand if you overall have short or long transactions, for example. Here are some top list longest service crate spans. We can here immediately see what transactions, or essentially what services are slow. And this is also linking to the trace ID. So if we click this, we'll be brought right into the Jaeger UI, where we can dig deeper into the particulars of this transaction, right? Here's another graph over service modifications. So again, with just 2 data points, it's not too interesting. We just have these 2 data points. One of them, it took us a minute, right? The first one, 60 seconds. Second one took a second. So that is precisely what this shows. Here we have waiting for transaction lock. So I'm the single user of this system here, right? It's running on my computer locally. So we're not going to see that, grabbing the transaction lock is not going to take a long time. In this case, it's less than a millisecond. Sorry, less than a millisecond. But if we have a busy system, in particular, where you have a lot of concurrent transactions, or a lot of users are trying to perform transactions concurrently, then you're going to see that they have to wait for each other, right? And then this time will go up. You'll have to wait to grab the transaction lock. And this is another graph sort of showing the same thing, but from a slightly different perspective. The red part here, it shows when the transaction lock is being held. So here we can see that at 14:13:30, we started holding the transaction lock, and then pretty precisely a minute after 14:30, it is no longer held, right? So that was the first transaction that took a minute, and then the second one here, it just took a second, right? We can also see the queue length in there. So when you have many concurrent sessions that want to perform a transaction, they're going to have to wait for each other, and that means that the transaction lock queue length is going to build up. So any value really where it's above 0 means that you have certain back pressure. If it's a low value, that's probably okay. But if you have a higher value here, that's indicative of back pressure in your system, probably something that you should look into. There are some other top lists here. Longest device connection, time it actually takes to connect to device. It's empty here because we don't have any devices in this test environment, etc. We have some rollback file creation and data validation that shows how much time we spend in a transaction. So that could also, it could be indicative of, if you have very complex XPath constraints or something in your models, you could see the data validation time consuming a quite large percentage of your overall transaction. So that would be something to look out for, right? Okay, and let me just, I'm gonna go back here. We can just run a what's it called? Simple test target here that will actually run things concurrently, so we can get a little bit more interesting test data out of this. So here, what it's going to do now in the background is start up, I think it's 10 different user sessions that all try to perform and commit the transaction. And each of them takes about 2 seconds because it's doing a sleep in there. So we can see that here now. I'm sort of refreshing the data. I can actually set a refresh here. That the service modification, they end up right around 2 seconds, right? I mean, the variability here is not, it's not a lot. If you look at the axis, we're between, there's a spread of, I don't know, 15, 20 milliseconds or so. We can look at the, waiting for transaction lock, and this has now gone up. Imagine those 10 transactions, right, that want to proceed, and we can only do a transaction at a time. So we see how the timing here goes up about 2 seconds for every, it takes like steps of 2 seconds all the time, right? And we will hover around 18 seconds, right? Because each transaction takes 2 seconds, and there are 10 of them, and one is currently executing, right? So that means 9 of them are waiting, and 9 times 2 is 18. Similarly, the transaction lock queue length, perhaps that's more visible in this graph, has also gone up, so that this shows that there are now 9 transactions that are waiting for the lock. So this is a pretty clear indication of back pressure in the system. And now it runs, I don't know, 30, 40 jobs in total. So we're going to see here how it's now done the majority of them and are ramping down to reach a queue length of 0 again. So this is the kind of data that you can get out of this, which I think it's a pretty nice way of looking at your system and understanding your system. So is this the same as monitoring? Is observability the same thing as monitoring? And I'd say no, it's not. Observability is related but not equal to monitoring. Monitoring is about the known knowns. So we know that our application can run out of disk space, right? So we can monitor it. We measure the disk usage, and once we pass a certain threshold, we can take some form of action. We can raise an alarm, or maybe even do automatic remedy somehow. But this is a known failure scenario. We know about it up front, and thus we can sort of monitor for it. So I think of monitoring as a subset of observability. What we monitor is by nature observable, but observability also goes sort of beyond this, right? And one of the more important parts of observability is to be able to perform post hoc queries. So after something happened, we want to be able to dig into our data and understand what happened, and perhaps even more importantly, why it happened, right? And this requires a completely different level of data collection. We have to collect data that we initially didn't even know what to do with, right? Now, fortunately, the overhead of collecting progress trace data in NSO, even at these, at the verbosity level of very verbose, is really sort of negligible in terms of performance. So you're not going to see a performance degradation from this. Just be sure to stay away from the debug level of progress trace, because that is most definitely noticeable. So that's something you can do in development, but not in general for production systems, right? So we can use the same set of information, the data that is exposed through the progress trace API. We can use that both for monitoring and for observability, although, once we collected it and we use it in slightly different ways. And I really want to sort of focus on this post hoc query, right? Because what we want to do here is expose enough data from the system that we can answer arbitrary questions, or at least some sensible level of arbitrary questions. You want to be able to form a hypothesis about something. You want to be able to have a gut feeling about how your system behaves, or when you see a behavior, you form the hypothesis, like, is this because of something, right? So, well, in this case, I believe the low transaction throughput of my system is due to sync from taking a log. So that could be our hypothesis, and now we want to validate this with the data that we get from observability. So we want to essentially query it for this question, or answer this question: is the low transaction throughput of service request strongly correlated with sync from operations? And that in turn would be a strong indicator that one. Then you'd have to answer what caused the other thing, right? But at least with a correlation, that's a start, right? And doing this kind of thing in Grafana, writing that query is a fairly simple thing to do. So we must be able to form post hoc queries, and this is perhaps one of the biggest differences between monitoring and observability, right? And in doing so, we just cannot require changing code. Most of us don't have access to the NSO code base anyway, but even if we did, we don't want to be dependent on that. We want to be able to collect data generically and then look at it sort of after the fact. And with that, I'd like to conclude this first peek into observability and monitoring of NSO using progress trace and these off-the-shelf systems that are available for tracing and graphing. I'd like to invite you to come along for the deep dive where we're gonna, for more in-depth understanding of what's going on here, the concepts and how we can use it. And even, I want to stress this part, right, that it's important. I've shown you some visualizations, but for your system, there are probably particular performance characteristics that you would like to understand about your system, because your services look a certain way, and for that you might need to customize things, and we're going to look at how we can do that in the second part, and how to instrument things further if we want to get even more detail. If you want to dig right into it, you can grab the package that I've written for this. It's called the OpenTelemetry Exporter. It's free, it's open source, it's available from the NSO developer space on GitLab and GitHub. This is what exports the NSO progress trace data to the Jaeger tracing system and to the time series database that underpins Grafana. I also want to mention you probably want to use NSO 5.4 or later, because the progress trace format got quite a significant improvement with 5.4. So when I initially wrote this OpenTelemetry exporter package, it required 5.4. Since then, we've added a sort of a backwards compatibility shim, so it works with 5.3, maybe even older versions I haven't tried. But nonetheless, some things are simply missing in 5.3 and earlier, so 5.4 is going to give you a better experience. I love comments and questions, feedback, so if you have that, please do not hesitate to reach out to me. Okay, thank you very much for your attention. Thanks for listening. Be in touch. All right, cheers, bye.